Hi, this is Pat Gahn, manager of the Ubuntu Server and OpenStack team, here with the Ubuntu Developer Summit, June 2014, and we've got Scott Mosier who's going to give a bit of share some knowledge about Simplestreams, do a tutorial among other things. So I'll just pass it to you, Scott, and you can just go.
All right. Hello, I'm Scott Moser, author
You're the
of...
server nice guy.
Yes, I'm the server nice guy. So if you've ever had someone be nice to you in the channel, in an IRC channel, it's been probably me. So largely, just an overall general introduction to Simplestreams. Simplestreams it's a data format and a Python client library, and a command line client to interact with that data format. We publish a number of different things. Canonical and Ubuntu publish Simplestreams data to describe things that they have for download and information about our deliverables. That's a high-level overview. Juju uses it. The cloud images a lot use it. So I will say, let's see. I'll try to share my screen here, and then we can maybe. Okay. All right. So can we see this screen here? Yes. I hope. I'm going to say yes. All right.
Yes,
so,
I can see it, and it's a nice size.
All right. So Simplestreams is all JSON data. It's inline GPG signed, so that the format has been designed to be secure and easily mirrorable and race condition adverse, whereas the apt disk format kind of has some inherent races to it that are a pain to deal with. But so we had run into that and explicitly designed to avoid that. So generally, it's a bunch of data that kind of has arbitrary tags and key value pairs. I'll show you, try to show an example here. There are two different primary formats, index and products, and I'll show you those. And then also, I pasted in the channel, but also in the Etherpad, there's a link to where I've got my notes for this talk and stuff, so you can just check those out and read them offline if you wanted. So this is the index. This is a trimmed down index, and basically all the index is an index. It lists other things, other streams files that are available. And this one is an example of the cloud images. This just shows some cloud images on Amazon, and I've trimmed it down to only show the 3 regions listed there. We have lots more regions and stuff on Amazon. It says that the data type there. So basically, let's see, this item. This is a content ID. And so an index is a list of content IDs. The content ID then has a path to where that file that's referenced there is found. That path is relative to the root of where a root, and underneath that, like this file would be at streams v1 index.html, and the other file is at streams v1 there. The index is chosen to kind of show some information about what's available in that path, in that subsequent file, so that you wouldn't have to pull it to figure out what products were in there. You could just read the index and say, oh, I'm not interested in any of those products. There's no reason for me to go into that file. It also says that the format is products 1.0, and the data type in there is image IDs. Those are just random key value pairs. They are not terribly important. I can increase the text
So there
size.
isn't.
Yeah.
So Scott, there isn't, like, you said it's random key value pairs then. So we could put anything in here?
Yes, they are not well defined. They're not restricted in any way. Let's see.
Because I guess it's basically some data around, this is a stream of data around it, and it's all about whoever's going to consume it. So as long as whomever consumes it understands these key value pairs, it's good.
Yeah, right. So there are certain keys that are expected, that have special meaning. Like here, really, path is just a key, just like in the same way as cloud name is or data type is, but it has a well-defined, or a known meaning, and that means that it references a file. Format is the same. It references, that means the format for the thing. But you could have arbitrary ones as well. So let's go to the example products format, which is, this is really what defines our data. And I guess this is an example of of download data, not of Amazon data, but so I kind of cross those. But this is the download data. It says its format is products 1.0. Data type is image downloads. And then for products 1.0, each product, there's the top level is a products dictionary. Products are something that act in a certain way. Essentially, they are something that gives you a stable ABI, for lack of a better term. Let's see. Move this one to done. Okay. So anytime you see this product, 1404 AMD64 Cloud, you can know that whatever expectation you've built upon that, the behavior you've come to know, you can expect. That's the idea, is that that's a stable identifier essentially. So obviously another one would be 1410, right? That would be for the next version. And then here we have just some tags that are on this. This is releases trustee, version is 1404, and Arch is AMD64. And then this product has different versions. This is the current version. The versions is also a dictionary, meaning it's unsorted. And in order to get the newest version, that is C locale sorted. So we use things that are YYY MMDD format, so that they are ever increasing, but anything you wanted to use that would sort that way is acceptable. And then multiple versions. Each version has some items. For download, we have a disk image and a root.tar.gz. The root.tar.gz happens to be used for LXC, and the disk image is something you would publish to your OpenStack. But they're kind of random things that have meaning known to the consumer of it. Here we've said F file type, and then because this item has a path, it indicates that there's something to download there. And then it's got a SHA 256 sum and MD5 sum, and it also has a size. And then let's see. Yeah, that would normally, and then I didn't show the inline. That's not the inline signed version, but you can see that if you just scroll through our URLs and things. So let's see, that's a general overview there. Basically, products have versions have items. And so given that high level example, I'll show you, just start playing with it. We can take some questions if there are some. If anybody has one, feel free to ping on IRC at any point, or Pat or Robbie, if you think better clarification is needed, go ahead. Again, now this is, let's see. So this, everything I'm doing is available at this URL here that's seen on the screen there. But basically, I wrote a very simple wrapper around ssstream query and ssstream-mir, which are the two binaries that are distributed with, or executables distributed with Simplestreams. And all this really does is allow me to use these aliases to these long URLs, so I don't have to type them during this thing. It doesn't do much else other than call that program. So essentially, that's it. I'll just walk through some of these examples that I've gone. So, I mean, at this point you probably wonder, why would I care about this? What data? What can I do with this?
Yeah, well, I was going to ask that question.
So let's see. So that was a simple little wrapper, and I'll show. So we publish data about our cloud images. You can see them data about what's there on Amazon, and we sign that data, and so that you can securely say, what's my latest image ID, and things like that. Answer different questions. So if you see, let's see. I'm sure you're likely familiar or have at one point or another gone to cloudimages.ubuntu.com and this website, and maybe you've even done a wget of something like just downloaded the current release and used a disk image or something there, and that's reasonable. We're definitely keep that website manageable by a human, but if you want to do things automated and want to deal with keeping up a mirror or whatnot, we've tried to make that easy to do with Simplestreams.
And I think you were just going to tell me if you weren't a human and wanted to do something.
Yeah, if you want for robots watching the stream or watching this. Essentially, yeah. So here's an example of what you might want to do here. I'll run that with dry run so you can see. I wrote my little utility, but I wanted to show the ssstream commands as really that's the thing that's distributed with the package, and you can get that. The mirror, that little utility is available in that repository, but it's just a wrapper. So essentially, if I want to mirror cloud images and all the data if I want to mirror all the data on cloud images to a local, I can do that with that command. So I'll do it. I'm going to do that.
No, you can't do that.
Let's come on now. There we go.
I thought you'd have that on all your systems. You don't have it set up like if Moser's system install it?
This was a brand new, I by design made this instance from scratch so that I could document everything I did, which I forgot to do this, but but yeah. So so there we go. And that demonstrates how we get secure data to you. So the Ubuntu Cloud Image keyring is distributed as a package. It's the keyring. It has a public key for everything that's signed on Ubuntu Cloud Images. So you can then when Simplestreams downloads that trace up above here, this trace here is saying, very non-user friendly wise that that I failed to verify that, so something was wrong. And now, this time it'll work. So what that did is just download. It did not actually download all that data, but what it did do, because I had said no item download right here, it didn't download the items. It did not cross into the paths, but if it did, it would have gotten, what's that, 225 gigabytes of data. That's what we have available for download there. Let's see. So at this point now, what that did was it mirrored what was available on cloudimages.ubuntu.com and put it locally. So now I have these files locally. Yeah, I have those files locally. That's what was described by the index there was these other files, and it went and downloaded them, all of them. Now, because I want to show that there's also the unsigned data there if you wanted to do that, and since I'm creating a local mirror of that data, it makes a lot of sense for me to go ahead and download the non-signed data because, well, I guess if I if I did that over a secure transmission channel, now it would be secure. Now it's on my disk, and now I can query the unsigned data. I don't need to run through the GPG verification of everything. Anyway, so now after having run that, I have some other files there. So now I have the JSON files there as well as the .sjson files. So let's see. So basically, that shows mirror. Oh yeah, and now that was mirror of with -- no dash item data, right? Which meant don't download the stuff. If you did want to download things, I'll show an example of for Ceros. For Ceros, it's my little cloud image thing. I also make Simplestreams data available. So here was a query of the data that was available for Simplestreams, and I ran that with max equal 1 and pretty. So I queried the data and said only show me the most recent thing, the most recent items of each product. And if I said, oh look, the stream there is released, and I happen to know there's also stream equal. Let's see. I happen to know there's 2 different streams there, but one is devel and one is release. So say I only wanted to match on stream equal released, then I have now I'll only see the released ones, and then I want to say go ahead and I want to go ahead and mirror that here. I'll make one more thing to that. I'll add ftype equal disk.image and go ahead and mirror that to explicitly using tins there, so I get the one from trunk, which has the progress because I wanted to show that nice. What was it? There we go. And
so what is it complaining to? What is it complaining about now?
That was just order of parameters.
Okay.
There. So now essentially I said, download all that, all of the things that matched that explicit query. Those were. So now I'm doing a full mirror of the data there for the AMD 64 image and the i386 image that's available on Simplestreams. And now find from. So that just downloaded all of that. So and that download happened to not be secure because I pointed at a .json file. But yeah, if you point it at sjson files, then it'll check against GPG keys and verify, and so securely download all that stuff. So that's mirror. That's SSStream mirror. It basically allows you to easily mirror some data. So if you want to keep up a local mirror of the cloud images and only want to keep the AMD 64 ones or the i386 ones or only the disk image, you can filter down, or only release equal trusty, you can filter down, kind of drill down and only get the pieces you need. So let's see. I'll move on to showing the S query a little bit now. So this basically, this is the example, a simple stream query. Again, there you pass the keyring so that it automatically, so the GPGs are checked. And here I'm going to do -mice pretty and dry run. So, and so that what that's going to do is crawl all of that data on Cloud Images and dump it to the screen, right? And so there is a lot of data, well over 200 or I don't know, 300K of metadata on Cloud Images site of ubuntu.com.
Oh, okay.
So that shows you can see, this last one here was the AMD64 disk image, and what it's doing, what the query is doing, is showing you each of the tags that apply to that item, and so there's all these tags apply to that item, and so you can go down and as you look at that, you can say, okay, well, I want to only say, you can query based on anything. So say if I wanted to say, I could do SSStream query. Let's say I wanted to and do SHA256 equal. Clearly, this isn't a very real thing, but that's going to only show me, my results then only showed things that had that SHA256 sum on them. So you could query on anything. The operators that you can use there are tilde, equal, not tilde, and not equal. So those are just, the tilde invokes a regular expression. So you could say, show me everything there that is release tilde trustee or and then it's going to filter out anything that isn't release trustee or release precise, right?
Now, Robbie, you use this. This for some reason is making me think of vUDS. So you're using this. I know you use Simplestreams in vUDS, right?
Right. So vUDS has got the capability of syncing a local libvirt volume store with cloud images that are published by somebody, specifically Ubuntu here. So it uses Simplestreams to do this. So the reason this looks familiar is because what you're specifying when you ask vUDS to do a sync is you're specifying a Simplestreams query filter string or set of Simplestreams query filters. And vUDS just does a Simplestreams query effectively against the filters that you provided and assumes that everything that results is the set of images that it should sync to the local libvirt store. And it's nice because it's all authenticated. Really nice property of Simplestreams, and one of the reasons we've done it is because it not only provides all the metadata, you might get that through some kind of API, so we might have implemented some kind of API server. But then any mirror would need to implement the API server. So this is really a flat file API, effectively, with a library, so that we can mirror the metadata, we can mirror the data, you can mirror a subset of the data or metadata, and anything that understands this format can then just be pointed to the mirror or the subset. And as far as it's concerned, everything is the same. And it's authenticated all the way through because there are signed JSON files which have the SHA-256 sums, so it can be even your mirror in the middle or your mirror of a subset of our mirror can be used to download things, and the end user can still authenticate that these were truly published as official Ubuntu Cloud images.
Yeah.
And it's all HTTP, so it can be cached by a proxy server very easily as well.
Right. And yeah, and one of the things I guess I should have pointed out, yeah, the cloud, the paths, all of the paths you'll see there, by requirement, the content at a path will never change. So it's designed, that was done explicitly to, you know, allow for caching by any squid in the middle, anything that's caching it. If you've ever gotten a path, the content at that path should never change.
So imagine that you want to run.
How is that enforced? I mean,
only
that's
by
up
the
to the publisher. Yeah.
okay.
If the publisher screws that up, then they screwed it up. But yeah, essentially, if you've ever gotten a path, the content shouldn't change at it. So that it just allows. It means that you'll never get the wrong cache. You'll never get the wrong data through a proxy.
So imagine that you want to run your own private cloud, and it's going to run in some kind of enterprise environment where you're expected to have it firewalled off from the rest of the world. Well, you still want to be able to hit mirrors of things. You still need to get the latest Ubuntu cloud images to run in your private cloud. So what this allows you to do is mirror the subset or the whole thing of the official images, verified and authenticated, and then everything inside your network can just point to your mirror instead, and everything will work exactly the same. Juju uses this as well, so when you get your Juju tools, your Juju environment needs access to it in order to be able to deploy instances with Juju running in them, then it works exactly the same way. So this is really a kind of a single global data metadata service that can be authenticated, that can be mirrored, that can have subset mirrors, easily cached, works all the way through, so end-to-end authentication still works. And so it really allows that kind of isolated use case to work without having to have a dedicated mirror set up for every single piece that you need.
I'll jump back in to my screen share session. So up above there, I was querying and dumping data from UC release, which was hitting the remote URL, as you can see there. But since I did a mirror of that, I can just as well point it at my local file mirror. So instead of doing that, I'm going to do this and point it right at this. It's the same command basically, but point it only at the local one. So I can add those same filters on. And then that just did a local disk operation. And so still dumped all the data that was there. So that's nice in that you can, if you're constantly querying image IDs or whatever, you can put a local mirror once a day and then hit the local mirror instead of constantly pulling that. Because as I said, we've got hundreds of kilobytes of metadata. I mean, it's honestly, you can feel the download. It's amazing how much metadata you end up producing. And to show an example of why we have so much, we'll query the Amazon portion of that, which is the largest. We have the most things on Amazon. Amazon has so many regions and so many different image types and everything. So, so I'll query that, and I'm going to go ahead and do So that pause there was actually the download of all that data, and so I'm going to go ahead and do. I can then instead query the local. So that was doing a remote. I'm going to query from now on just do the local cache just because. So dry run. I want to see that would do that. But let's say I'm only interested in. Almost always, I'm only interested in -maximum, and I want the most recent thing. And say I want arch equal AMD64 and release equal trusty. There, now I'm querying the local data that get me all of that. But that's not necessarily the most useful output format. So with SSStream query, you can also say. Show me this specific output format. And you may have noticed in that, from what's above there, you can see some of those fields, region and pub name. So all I'm going to do is query on those explicitly and output only what's only those things. Type that into sort, you can see, and then you might notice that you're like, well, why are there 4 of the latest things on US West 2? What's the difference there? Well, let's see. So on Amazon, we have, I guess if we did, let's see. That's a fair amount of data. Oh, that's still a lot of data. Oh, come on now.
Why don't you filter it just for US West 2, and then you'll see how that varies.
Yeah.
Region.
So yeah.
Okay, got it.
Yeah, we can just say the West 2. And so there are still several of them there. And you can see that the difference there is this one here is PV, and this one down here is vert PV. The one up there's a vert HVM, and the other thing is root store. And you can just by looking at the output, you can as a human figure that stuff out. There's no well-defined set of these, but Canonical, when they publish this, we'll always keep root store and vert. We're not going to change arbitrarily the keys that are on the things. So we may end up adding some, in which case, basically, as Amazon moves through time, we end up having to add the vert type because they added a new virtualization type, which was HVM. So as we could iterate, what we really want to do is see all of the fields printed out there. So there's my query for that shows on Amazon, is reasonable, and so then I can say that was a secure query. It told me that this thing is the latest thing for Trusty, and that it's AMI ID. So then I can launch that.
So that's it with Amazon, isn't it? We publish images for every region, for every vert type, for instance and EBS. So
yeah.
So these all multiply, and we end up with hundreds of AMIs being published.
There's the number of things we have on Amazon public right now. We have 5,358 things published on Amazon. It's amazing the multipliers that you have. And how quickly it grows. Now, of that, to be fair, 294 of them are the most. Yeah, that shows only one. No, I'm not even sure what that shows. I have to think about that. We have a whole lot of things, and it ends up being multipliers. So we also have data there for Azure, for all of the public clouds that Canonical has data published on, official Ubuntu images. We have data published about them. So here I just did. Oops. Funny. I just queried the local mirror for, and I said just grep for Windows to kind of show that there's virtualization vert type there is Hyper-V. This shows the endpoint and the region, and for cloud images, our basic assertion is that if you know the endpoint and the region that you're talking to, that basically defines a cloud. Within a cloud, you may have multiple regions, but an endpoint and a region is a unique tuple that defines something. So say I had just done that, and then I want to filter down. I see that I don't know that. Let's see, that was on Japan East, and so I can do and say show me all the things that are on Japan, that match. There I did the region that has Japan in it that matches Japan. So I can say show me all those things, and what this shows, so this is the latest the latest images in both Japan East and Japan West. And this shows a, oh boy, there's some problem there, as that shouldn't be latest. I wonder if that's the case. Check US. It would seem that.
So Scott, what are we looking? What are we looking for right now?
This is, I mean, here I'm querying all those ugly strings are the image IDs on Azure.
Okay, good, because all those strings, they start to boggle my mind, so I had to be reminded.
Yeah, they are. Yeah, that is an image ID on Azure.
I think you might be sending me subliminal messages through all these characters, but I'm not sure.
Yeah. So when Robbie put in the MD5 or the base 64 encoded data as the libvirt volume, other people had come up with similarly ugly conventions.
Yeah, well, that was a bug. It'll go away.
Yeah. But this one won't. So anyway, that's it. But essentially, for any cloud we have, you can basically use SSStream query and get the the official AMI IDs. The fact that the region there has a space in it, and this is just space output delimited data, shows that I really should add a -- delimiter flag or something.
So Scott, would a general user ever be running the Simplestreams commands? So it sounds like someone that was potentially hosting a mirror behind a firewall would be doing this sort of thing.
Well, if you want to launch, so Azure is not a great case, but on Amazon, if you want to figure out what the latest official Ubuntu image is on Amazon, you can look through their let's see, gosh, I mean, literally hundreds of thousands of images and find one that you think is the right one. And there's a fairly large possibility that you're wrong. So as a user, you can use SSStream query, or you can write tools that would query that same data and securely find out what the latest image is as Ubuntu defines as the latest image. And that's honestly, this is the only. You can also get it through the old Query 1 method, but that wasn't as well mirrored, and it only worked securely because it was done over HTTPS. Here you can mirror it locally and then query it locally.
So we did have a tool in Cloud Image Utils called Ubuntu Cloud Image Query, which goes back to the days when EC2 was the only real public cloud. And you could do things like, I can't share my screen easily right now, but you could do things like Ubuntu Cloud IMG Query instance trusty US East 1, and it would give you an AMI ID, which would tell you what the current AMI ID is for starting a trusty instance on US East 1. That is an instance type as opposed to EBS. I imagine that at some point, I mean, SStream query basically provides a superset of that capability. You can use it to ask for any public cloud's image ID in the region that you want, for the release that you want, and so on. So I imagine Ubuntu Cloud IMG Query will eventually be replaced by some kind of SStream query wrapper that works for all clouds.
Yeah, definitely would like to have more friendly, and that's, I mean, essentially kind of what this vUDS tool is, right? It's a simple, more I'm aware of Ubuntu things, little wrapper. To show another use case, I'm sure a lot of people have essentially done or scripted, and used possibly in automation, something like wget that thing, get the latest daily or the latest released image of that thing. There's no real easy way to secure that is to ensure that was downloaded securely, and there's no real easy way to mirror that.
You put an S in that just after the HTTP.
Yeah, you're right. and that will do it. That will download it securely. It makes it difficult to mirror.
Yeah, you can't cache it, you can't mirror it, etc.
Yeah. So SSStream query can. So I'll just show a little example of how you would download that securely using the SSStream query tools. So here, query the download data, and all I'm doing is hitting a specific URL there to filter, because I know that's the URL. I'm avoiding the other URLs, the Amazon, to just filter out data from the get-go. So let's see. So what that shows, if I do that, a bunch of data there, and now what I can see, let's see, if I want to, if I'm going to download something, I want to see the checksum and the URL. And so this command here, one of the fields that's kind of added to the data for SSStream query is item URL. So there is for each item the URL and the SHA 256 sum. So given that, I mean, that was fairly easy to get. Just go check that. So this, there I filtered by release equal trusty and disk one image. So now I've got a URL to that. I can say that use simple shell things there, put that into a file, and then I can say get that URL. I wonder how fast it's going to come. There we go. So I download that image, and now, so I had written, basically based on the output of that, I wrote that little sums file, and then I can just use SHA 256 sum and verify. So right there, I checked that went down the whole path of verifying the download data, the metadata, download, check the checksum, so you can be ensured that what you got was clean and actually distributed by Canonical rather than what was.
No, are there? I mean, there are friendly little tools for doing.
For doing that.
Yeah.
Those friendly little tools, I think, are codified all over the internet as that wget known URL.
Because all I know, like, I think what you've shown is really cool. I'm like, I'm never going to remember all these.
Right. There are, as you said, yeah, we need friendly tools for those sorts of things. They're not there, but as Robbie pointed out, basically SQuery provides a superset of the data, and the data is there. We do need simplification things, but if you're a developer and you're looking to write some little, a little hunk of code, it's fairly trivial to do that and to then securely get those things, rather than just hoping that no one man-in-the-middles you and
so
let
as a
you
developer,
take advantage.
What this gives you is the ability to put together something where you can securely get access to our metadata in a way that can be mirrored, cached, authenticated all the way through.
Right. So it's one of the, I guess I got a couple more things I'd like to show on move. So
yeah.
So let's see. This is this example sync, which is at that URL. Again, these notes are in that GitHub repository, so you can see them there offline. But that URL is what we use to mirror the images on cloudimages.ubuntu.com into a cloud, into a Canonical stack is what we call it, but basically an internal Ubuntu or an internal OpenStack. And so what happens is that uses the glance mirror, and glance mirror basically mirrors the cloud images data into glance, and it also publishes data on that, and so then it publishes into Swift data about that. So let's see, and so basically what it does is then publishes into our Swift at that URL a bunch of data that then is queryable by Juju, is queryable by other tools. So essentially, you can have the same Simplestreams data for your local cloud that we have on our public clouds we have available on cloudimages.ubuntu.com. You can easily produce that same data on your local OpenStack and then use whatever tools you've gotten to do Simplestreams Mirror or to figure out what's my latest image ID. You can just point them at the entry point for your local cloud images. And then the last thing I've got is just, so obviously as other formats go, reading that data is not the easiest thing in the world. So we have, just for launching images on Canonistack, we do have something called CStack, and then CStack just has very simple, CStack has got very simple usage, like CStack Q run for query and run trusty, and then it knows the Nova boot commands that it needs to run to do that. It queries gets the image ID and runs it. So essentially, just a lot easier way to then again securely you can figure out the latest image, grab it, pull it down, and use it. So that's all I have. Fun, exciting metadata and data.
Yeah. I think the thing is we really we need to figure out how to invest some time into the simplification, because Scott, that is cool stuff. But wait, even watching you, even the god of Simplestreams here, you're mistyping things from time to time.
Yep.
so it would be really cool. And you like that I gave you the title God of Simplestreams now.
Yeah. No.
King.
And it's definitely, there's definitely improvements that can be done. I mean, as you can, it basically that sQuery thing, that little tool I wrote basically had the knowledge, the alias of Ceros to that endpoint, CStack to that endpoint, and and we don't have a good.
So where do we start? So in terms of so I think what would be really great, Scott, is if you sat down and kind of wrote down your thoughts on kind of some tools to simplify this. And I think maybe I should watch the video game again, and that will give me some clear, like, okay, the things he showed off are clearly the things you should do. And then we just start working through them over the next few releases.
Yeah, I think likely you'd just like to be able to, without knowing a long URL, it'd be nice to be able to say, give me the latest image on cloud X in region Y. I'd like to mirror mirror the data there, or even a secure, basically like I showed, get me the latest disk image of Ubuntu image and download that securely. And
we'll sit down and we'll plot.
We've got a lot of metadata there. The data is in a reasonable format. It ends up being a lot of data, and so it is. We have a bunch of raw tools at this point. They're very generic, but they're not very user-friendly, so to say.
But it's Scott Mosier friendly.
This is actually the most. I was happy today because most of the time when I would try to do something like this, I'd try to use a tool and then I'd find out that, crap, that it doesn't really do what I want it to do because it's missing this feature. And really today the only feature I found missing was the delimiter, or the output format should be able to specify delimiter so that, because space is clearly.
All right. Well, we'll sit down. We'll sit down and figure out. Now, so if someone was watching this and said, "Hey, I would like to make this simple command," how do they contribute it?
I'd say the Simplestreams project is Simplestreams is on Launchpad, and merge proposals are accepted. Bugs for, hey, this is functionality I want, or would be accepted. Just it's an open source project, so treat it as such.
Cool. All right, Scott. Robbie, you got any questions? Let's see. Wait, are there any questions? I think people are just
blown over by it all.
yeah.
IRC's been very quiet.
They all got hypnotized by all those numbers on the screen. So everyone's
Or the MD5 sums and SHA-256.
exactly. They're hypnotized. So there you go. If you're hypnotized now, come out of it. All right. So thank you so much, Scott, and have a wonderful day. Take care. Thank you, Robbie.
All right. Adios. Thank you.